previously we were looking at the various types of plots and the figures. Uh, we saw several types of plots: line, bar, staircase, error bar, polar plot. Then we consider stems, scatter, the pie chart, bubble chart, then the special charts like vectors and the compass. Later on, we considered how to format and how to do the annotation of the corresponding to the graph, like X label, Y label. Now we know how to enter the title for that, how to give the legend, right? How to specify the axis limits, whether to go for a grid lines, right? Compact grid lines or not, etc. Right? And we also considered how to print, right, the specific graph, how to save it and how to open it once again, right? How to uh, perform the saving and how to save in the default format in MATLAB. Okay, so all those concepts we have covered already. Okay, so next we are going to the next topic. This is the scripting. We'll consider the scripting in MATLAB. All right, so scripts are the simplest type of a program file, right? So this is basically the simplest program file in MATLAB. Okay, so these scripts are used for automating a series of MATLAB commands, right? I want to run many commands in a series. So in such cases, we can use the scripts. So why they are used? For automating series of MATLAB commands. Right. So what are the commands that we are using, such as computations that we have to perform repeatedly from command line, right? So instead of, if you write it in the command line, we know that we have to execute it again and again, right? So just to avoid that, whichever you want to run repeatedly from the command line, we prefer using the scripting instead, right? So what are the options to create the new script? So to create the new script. So we have multiple options. All right, let's just check what all options we have in MATLAB. So the first option is directly you can go to the MATLAB command window. All right, so let me do one thing. So the easiest one I'll tell you first, right? So you just have to come to the top and simply I have to click on the new script, right? Simply click on that. So as soon as I click, a editor window will open and there you can actually type. This is the technique number one. Okay, so that's the easiest one. Then second one, using the edit, right? So simply type maybe this is my code 1. All right, so if it is there, it will open. Let me check whether I have a my code 1. No, it's not there. So it will open a new one, right? It will create a new file in the .m format by the name, whatever you specify, and it will open that. So if there is something like which is already existing, right, then you can see that it will open the existing file. That's all. So for example, I'll write edit maybe I'll type which one, the one which already exists. That is my for loop. All right, my for loop. And as I press enter, you can see that it opens that file which already has been entered. Okay, right. Now let me show you the third way to do that. I need some of the commands to be entered for that. So go with the CLC first, then I enter something, then I go shift enter so that I will not run. Okay, so then let me enter the for loop as it is. Then this. Let me assume that I actually have, I'm running some instructions. Okay, so then I'll type, then I'll type X, then I press say enter. Okay, so something it's already there in the command window. Now, actually I did something in the command window, but now I want this part of the code to be present in, I want this to be saved in the form of file. So what you can do, simply copy that portion of the statements which you already ran in a command window. Okay, after doing this, simply right click on that, right? And so you have an option here, right? So you can actually select this part and just a second. Let me bring this up. All right. So let me, okay, over here I can do that, right? So just select, sorry. All right, you see I actually have selected that part of the code, and then you go to this and select create a script, right? So as soon as you click the create script option, you can see that a new file created, but now there is no name for that. Okay, so but you need to save it once again. You see that my for loop from where I actually had copied earlier, it is there. I'll just close this. So even you can close this. Now I don't want to save it. I'll show you the method once again. Simply go back to the command history, right? So as soon as you click, you will open the command history like this, and you can select, right, which are the commands which you want to, right, put it into the file, right? As soon as you go there and hold shift and keep pressing, now I have selected what I want, and I just go to the create script option. You see that a new script gets created automatically in the name untitled 3, right? Then definitely you can go for save option, and you can save what you want. Okay, all those options do exist anyway. Right now I don't want, so I'll just close it, right? It gets closed, right? So these are the three options we have in MATLAB so that we can create the new files, new scripts. Okay, so uh, let's go for uh, the creation of a file once again. I'll just go to the new script, and let me say I'll type something. Okay, is equal to 10,000. Okay, then maybe row is equal to 1, row is equal to 1. Then let me create bin is equal to, say, column divided by 100. I'll create some random code. Okay, then a random number generator for now. Okay, then maybe I'll create a list is equal to 100 into random, say, number of rows Okay, it's this row, I guess. Row, comma, column. And let me say, I'll create a histogram. Of list, comma, bin. Okay. All right. Now, you can go for Control S and save as maybe my uh, code 1. Okay, it's already there, but it was an empty file, so I can simply rewrite it. It gets saved in the same name. All right. So, uh, in order to run, right, if you remember, the first option to run is that you can go to the uh, run command and you can click here, right? So I'll just add a clear as well, just at the top. So this is clear and CLC. I'll just add those two lines so that when I run this, I can see that everything is clear. Okay, so you can see that the random numbers generated have been used over here to create a plot. All right, so I can see the plot, right? It's a code just to create a plot. All right, but you can see that to run, my first option is that I go to the editor. On the top I have to select this editor. Normally it will be, maybe it's present over here in the home. I have to come to the editor and then I can click. Okay, even if it is in home, when I come to say the editor, I can see the run command and I can simply click on that, right? As soon as you click, it comes. Okay, that's the first time to this. Again, I will show you another technique, right? So that is simply type the name of the file which you want to run. So my code 1, that's all. Okay, my simply type my code 1. That also runs the code. Okay, as soon as you type that, it is going to run. So you don't have to go to the run what you call run button always. You can simply uh, type the name of the file which you want to run. That is also going to run. Okay, so that's how to create the first option we saw so far. It's about the creation of the script, and later on we understood how to, right, this is to save. I just wanted to save in the second option, and the third option was to run. So these are the options we saw so far, right? How to create a script, save a script, and run the script. And now we'll go for to add the comments. Right. Let's look at the comments section related to that. So in this particular code, let me say I just want to uh, add the comments, right? So comments can be added, right, by simply entering the percentage symbol, right? Wherever you add after that percentage symbol, this will be considered as a comment, right? So this is a, a random code. Now you can see that it is being highlighted in a green color, just to show that it's actually a comment. So I can also add a comment somewhere here. Maybe I just want to add a comment here, means simply type the percentage, then write clear workspace variables, right? Like that. I can actually wherever I want, I can, right? Again, if you want to convert multiple lines into the comments whenever you don't want to, right? You just have to select that and come to the editor option, and you see you have comment option. Simply click on that So you can see that all the lines which you had selected earlier will get converted into the comments. Okay, this is one option, right? And I can remove that. I can actually cancel that. uh, I can revert that by doing this. You see, it actually goes back, right, to the original. This is the first option, right? Multiple lines you want to convert into comment, it you can do that simply like this. Okay, but there is another easier option. You don't have to select. You can simply write the percentage followed by a flower bracket. Okay, and in order to say where to stop, you will type percentage followed by closing of this. Okay, percentage followed by this, enter, right? It actually, the next line has to go to the new line. You can see that these lines are converted into you can see that they are converted, all the text has got converted into comment. And this is the way, easiest way to deal with multiple comment lines. Okay, so in order to cancel that, you can simply erase that, right? So I'll just erase this and I'll just erase this. So if you use percentage flower bracket open and percentage flower bracket close, whatever will come in the middle will be converted as the comment. But you see, one condition here is that whenever you want to do such a conversion, right, uh, the percentage and flower bracket open and the closing of them have to be in separate lines. Okay, you cannot club this with the previous lines. That will not work. Okay, so that's the only condition we have for this. So commenting is very important when you want others to read and understand the code written by you. All right, so that's the important aspect about the commenting. Okay, next is that we have an option that is used automatically. You can rename all the functions or a variable. Okay, so this is possible, right? MATLAB provides you a feature that helps in the renaming multiple references of a to a function or a variable within the file. All right, so that can be done. Let me show you that. Okay, but before that, let me enter what I'm trying to do. Right, the next topic is within the script we have the next option. So this still comes under the scripts, that is to rename uh, variables. All right, so let's go back. All right, let me check whether how to change the variables over here. Right, so I can see that as soon as I click, right, you can see that it highlights that particular variable has been used which and all places in the code. Okay, and now let me say I want to change this as CO2. You can see that it is actually suggesting me, saying that you have uh, right the COL and you have it's been changed. Now you see, if I press shift enter, you can see all the three got changed simultaneously to CO2. All right, right, so you observe that, right? So I'll change it, once again. So you can see it was CO2. I'll change it to COO. Now it, right, all the other occurrences of the same variable have been highlighted, while it is highlighted, simply use shift plus enter. So you can see that all the occurrences of that variable got changed into the new name which you typed just now. Okay, all right. So this itself I will show you. I had taken a snapshot earlier. Okay, so I'll show you that now. So to rename any variable, you just have to open any function, or maybe you just have to open the file where you want to change the variable's name, right? So after that, now you see I just have saved this. Now you can see it should be clear now. So in order to change the I into j, let me say I actually had I over here. I simply changed that 1 into j. At that time, it actually detected there were 5 i's in total. So it suggests that simply press shift enter so that you can rename all the i's into j's. So simplest, easiest way, you don't have to struggle. Okay, so that is one of the major advantage over here. Okay, then let me show you another very important aspect that we use regularly to convert our uh, program in, or the script into subdivisions. Okay, so let me show you that. So now we are going to consider that part. So this is to divide the script into code, into the code sections. Okay, dividing any code into sections becomes absolutely necessary, right? Say whenever we want to say do something that which I want to run part by part. I don't want to run the whole code in a single step. Okay, so that's what is my objective, right? For example, I'll show you a different part of the code, right? A different project which I had done earlier for a different student. Okay, so let's just look at that. What do you mean by the sections, right? You can see here, this code is not a single code. This code has sections, right? You can see the section markings, and right, when I click on a particular section, that section gets highlighted, right? So you see, if I click on this and I select run section, only that section will run. I'm not running the whole code. You can see this section says that clear close CLC. So when I am having the facility to run the section by section, you can see the workspace got clear because it has clear close CLC. But when I go to the next section and I click, only that part of the code will. Okay, so what is the use of doing like this? When I divide into several sections, right, we typically focus the efforts on a single part of our program at a time, right? So working with the code in chunks is possible wherever you do the core sections. So that's what is the very basic idea behind this. Okay, and also when explaining your file to others, right? Often we describe the programs in parts only, right? I'm not going to explain you everything in a single step. Part by part, I divide the code into several sections, and section wise I can do this, right? So to facilitate all these processes, right, we use code sections in general. Okay, so code sections are possible. We can actually bring the code sections into picture by simply using the specific mode called as a cell mode in the program. Okay, I'll show you now how to enable the cell mode. Right, I have two options. Let me show you the quick easiest one. Let me say this part of code is one section. After that, I want to start a new section. Correct? So in this, come to the editor section once again and select insert this option. You can see that insert a section comes into picture. That is getting highlighted saying that you are using the section option, right? I click on that, you see it actually added a line and it actually also highlighted the current section, which is the newest, latest one. You want to highlight this one, you can click on. Now you have the authority to run by section, right? Only that section runs. Then I come to this and I run section, only that section will run. Okay, I can now, you see, without using the clear and CLJ, I'll run this part only once again by just clicking on this, right, run section option. So this is the first way of creating the section. I can also do that by, right, typing two percentages one after the other, right? One option was to use the insert option at the top, and the next option is to use 2% at any point, right? If you enter 2%, two of the percentage signs one after the other, right, that itself will create a new section immediately after that. You also use this as the explanation for the that particular section. This is possible, right? So that will be considered as comment, whatever you type of that, then only you can write the code. Okay, so that's how the sections will work in MATLAB. So sections are very important, right? Now, what are the various options we have to evaluate with the various code sections? We'll see that. Okay, so this is option, this topic is going to help us in understanding the running of the code or options to evaluate code sections. So we created the code sections. So this is the next topic is evaluation of code sections. All right. So we can evaluate the code sections very easily, right, by using the options at the top of this window. You can see that the first option is simply evaluate or run the section. That section will run the current section. Okay. Then another option is that you run the current section and go to the next section, because once you run this, there is no meaning in waiting in the same. You have to go to the next. So there is an option called as run and advance. Simply click over there, it will run and it will go to the next. So for the last section, if there is no further sections, run and advance and run section is same, right? There is no advancement, simply it will run. Okay. Also, I run a section, I rectify the errors in that, then I want to go to the next, means simply you click on advance. You see that it was highlighting the first section. As you click on advance, it's not running that section, simply it will move to the next section. Okay. And also you have another option called run and time. It will actually count how much time it took to run. Okay. So that is the next option, right, what you have. All right. And okay, let me show you the details related to this. All right. So when my intention is to see the different operations associated with the evaluation of a section, right? This is what you can do basically. Right? We have the options such as you can run the code in the current section, right? That's also I mentioned, by simply clicking the run option. Right? And run the code in the current section, move to the next one, right? You can click on run and advance. All right, then run the complete code as usual, click on the run button. This is called as a run button. All right, then let's move further. Now let's see how to create the function, right? So the next topic that we are going to discuss now is to create the functions. So as we know from basics, if you want to use a specific part of the code repeatedly, right, in multiple codes, we write what is called as a function, right? It actually provides you more flexibility, primarily because you can pass the input values and return its output value, right? So first option is uh, to create. We'll see how to create, right, the function. So let's go back to the MATLAB window. And now, in order to create a function, you first have to create a new file. So we'll go to a new file, okay? And you specify MATLAB that you are not writing a common script, but you are trying to write a function. Okay, you can specify that by starting your code with the keyword function. So you can see that the color changes immediately because it identifies that as it identifies what you are trying to write is a function. Now write its output value. Let me say f is equal to, right? Give the name to the function like fact. I just want to write a function that calculates the factorial of some input value n. So you don't have to specify what is the data type, right? Like in C program, C++, you need to say that I'm passing integer n, right? And you also have to specify what is the output, right, etc. That is not required here, right? Now you see, factorial is pretty straightforward in MATLAB. F is equal to simply uh, uh, I'll write it's a product of 1 till that number n. That's all. And then I say you have to specify the last line of your function as n. Okay, then let me go to all right, fine. So after that you need to save. Now you see the function, this particular m file will get saved as a function file, and its name should be matching to this one, the name which you have given. So for that reason, it actually automatically performs that job. As soon as you go for a the save option, it gets saved in the same name, right? It actually types the fact.m. So you can see that the fact.m is here. Also, the icon is slightly different compared to the normal M file. You can see this is normal M file. The icon is different. You see the fact.m has the F written over there, right? This indicates that it is a function. All right, now the fact, this function is ready. I'll just call that function. You can call it in the normal way. Say y is my assigned output value. Y is equal to, call that function by the name fact, a fact of say 10, right? So you see, right, it actually thinks. So since I pressed f is equal to this, I didn't press a semicolon over there, it actually does this, right? So it types twice. So now let's see. Okay, so I'll call this once again, y is equal to 5. It types only once. Okay, so that's the 10 factorial, right? You can pass a different value to this. Say I'll just type 5, you see 120, right? That's the 5 factorial, right? So like this you can write what is called as the factorial, right? This is just a simple example to show you how to do that, right? We can actually write, in order to we can type a file using a different method. And there is another facility in MATLAB that you don't have to create a function separate in a separate file. You can do that even inside your what you call the main file itself. I'll show you that. Okay, I'll go to edit. I'll create a new one now. My file 2. Okay, it creates a new file, my file 2. I'll type now, say x equals to 3, and maybe y is equal to 2, followed by, let's say z is equal to, let me say I want to perform the permutation. Okay, so I'll call the function directly without defining that. Okay, perm of x comma y. Okay, but now you see it's not defined. First I'll define that here itself. So function p is output. P should be equal to of say n comma r. So permutation is right npr. Now what is the definition of that? So we know that the function which is the permutation is defined as output p is equal to, right, I use another function, say fact, right? So this is fact of the n, correct, divide that with another function fact of n minus r, out of which the fact is already defined. That's why I'm using this. Okay, then I go for end. So fact is actually present in a different file which is outside this particular function. And also you know that the function perm is written inside this, so it should work. It shows you that you can write the functions in the same file where you same m file, or even you can do that outside this. Okay, so let's try to run this. Okay, I'll run so that you can see. Okay, it ran, but okay, I'll just have to show the z now. So if you want to show that, just keep it. So 3p2, right? So the answer is equal to 6, right? That can be displayed over here using a simple technique like this, right? So the idea is that storing the function by within the same file at the end of that script, that is also possible. Okay, right? So using this we can do this, and then the next option here is to go ahead with what is called as the warnings, right? Because whenever we try to uh, do something, right, which may cause some sort of delay in the processing of that command, MATLAB issues you a set of commands called set of warnings. All right. So we have an options. We have an option in MATLAB to handle the warning, right? So that is controlling warnings. Okay, so the first technique is to enable. Okay, if you want to enable warnings, right, then the option here is you can actually enter that even inside the code, or you can actually enter that even in the command window. All right, so if you want to turn on the warnings, you simply write warning. You have to specify whether you want to turn on. Okay, and you can specify, right, what type of warnings you want. Most of the time we use all, right? Every warning that comes, right, will be displayed, right? That's warning being turned on. Okay, then you have another option to turn it off, right? That can be done by simply typing the same warning, but instead of on, you can turn it off. So that turns every warning that's going to come right? After this particular command will be turned off, it's not going to display any commands. Okay, right. Then the next option is to go for what is called as a class, right? So uh, you can actually create the classes like we do in any other programming language. Okay, so let's look at a class now. Okay, then we go to, right. So this is basically you want to define the object that encapsulates the data and the operations, right? These operations can be something like you can try to uh, perform those operations on the class which you have defined or on the data which is present inside the class. Okay, so this kind of data formats are called as classes, right? I'll directly show you the class that is being created. Okay, I'll just define a class and I'll just show you that. So see, this is an example of the class. So let's see, we define a specific uh, data called as the uh, class, and in order to define a class, right, we use the keyword called class def. So class def is the identifier which tells MATLAB that I'm going to define a class. Okay, that's the first thing. And once you define a class, you see here in this particular class called as a basic class, I'm trying to define a property and two methods that can be operated on this particular data. So the first one is a value, right? It is a property that contains a numeric data stored in the object of this particular class. Okay, so you have to specify the properties of the class in using the keyword properties followed by the variable name, right? So it's a value, then right, it you give a comment saying that it's a must be numeric. Okay, then let us say we have another value, another what you call method called as a round off. So you are using a method that is function r is equal to round off of some object, and how to round off something is written over there. Okay, some function, you can even change the function, and there is another function called multiply by. Okay, fine. Now you see the object dot value is nothing but it's in the property which is a numeric value. So that particular object, right, dot value. So you are actually passing the object to this particular function. In that object, whatever is the value, you are trying to round it off, and object dot value into n will be calculated by the multiply by. So you can see that as per the basic condition of the class, what we are trying to do, when I define the class, I define the property and the methods that operate on the data which is present in this particular class. That's the first thing. Okay, right. So using that, we define this. Now basically, what are the uses of these kind of classes? The first thing is that save the class definition in a M file. Okay, with the name same as a class. I define something like this and I save this as basic class.m. Okay, now you can actually create a class of object of this particular class and access the complete properties assigned to that data. So call the methods to perform any operation that is defined here on your data. So, right, without knowing the data, you can actually write the complete code, right, within this, right? For example, I'll show you the result. Okay, when I run something, I'm getting this. So say, no, I'm not running the MATLAB. I will because this typing will take a lot of time, right? So I actually has run the code and I have saved it. I simply show you the results so that I can save some time. All right. Okay. So this is what is the result I got when I'm running this. So I actually have typed this and I saved it in my command. And now I'm running like this, and this is what I'm getting now. Just a second. Okay. So you see here. So I try to define like this: A equal to a basic class means that basic class has been right assigned to A. A is an object. A dot value is pi by 3. So you see the A value is actually stored here, right? You see here, this is a value, right? This value what I had actually entered, right, is actually being used here as a property of the basic class with the name A. A is an object of that. So pi by 3 is getting assigned to A. I can simply use it when I want. So this is how you access the properties. Properties will consist of properties are the numeric data that is present, right? That can be used, right? Uh, that can be used to store the any type of data, right, related to that particular class. Now I'll also show you another use where uh, I try to run uh, I try to call a function. Okay, so that is okay. The function I called first, I called the function called that round off because I defined the round off earlier, right? So you see, I call that function a round off. Now, when I call that function round off, you see, this was 1.0472, right? I simply called round off, it actually converted that into the rounded off value. Okay, because you see the round off is already defined, right? Round off of that object means round off that object value in second dimension, right? So that's what it does. Again, I called the uh, a different function, right? That's the other function which is written inside this particular class, right? That is multiply that object value into a n. In the sense, I have to pass what object I want and what is the n value. So just look at this. This is what happened when I try to run that part of the code, right? I had pi by 3. That's that value I have here. Now I try to run the second part of the another part of the code by calling this function, that is multiply by a comma 3. Whatever a, it's 1.05, it's that's the value. Multiply that by 3, so you got 3.1416. So you can see this is the use of the code. Okay, then there is another environmental variable which is very important in MATLAB, and that is called as the search path in MATLAB. Okay, so the search path is basically subset of each and every folder in the file system of MATLAB. MATLAB saves its data in some files which may be normally present in the installation. Some of the files will come into your the personal folders, and right, you have an option to save it in very various options, various locations, right? All the folders are considered as altogether they are considered as basically what is called as the MATLAB path. That specifically defines what is called as the user path folder, which is added to the search path, and also the default locations for storing every possible file. right? So the folders provided with MATLAB and other MathWorks products, which are under the MATLAB root, or maybe the toolboxes, right? It's called as you can see, you can look at the folder by just using a command called MATLAB root. All right, let me show you that first. So where is the root? So I can type that in the command window. Simply type MATLAB root. So you can see that my MATLAB in my system MATLAB root is C program files MATLAB R2020A. All right. So this is where is the root is present in my system. Right. To determine if you want to check that whether a file is on the search path or not, right? You can run what is called as a which followed by the file name. Okay, so let's try that. So if I want to check whether a file is there or not, so you can type which, say maybe I'll write what is present over here, like FACT I'll type. So maybe you see that it's present over here, right? It's already highlighted. So it's present here, right? C users present document MATLAB page inside that. So if something is there or not, you can simply do this. But if something is not there, you want to add something new to that, right? Then you can go to the set path options over here, right? That is present in the home tab, right? Go to the home. You can see you click on the home option, right? And I have the option to go for a set path, right? So you can go to the set path, and as soon as you open the set path, this is what comes up. You can see when I come back to the set path option, I get a new window. That new window also I have actually taken a screenshot. I'll just display it, right? So that is like this, right? So a set path option will come, right, which actually shows you what are the various files that are present on your path. You can select a path and you can add a remove, or you can go for add a folder and you can add any folder to your MATLAB. Okay, so using that, you make that folder as one of the root folder in for your system. Okay, then we have another option here. This is to manage files and folders. I'll just show you one table which is sufficient to explain the complete concept of management of the files and folders. Right, the first option is to create a new folder, right? I can simply type this command, right? So mkdir is the command which is used to make a particular directory. Parent folder, it's the current folder, and new directory will be the name of that. Or I can actually make a file or folder, right? I can simply write myfile.m. You use a command called, right? You can actually move a file, right? Move file by this name to this location. Okay, and you can even perform the rename of a file or a folder, right? So you just have to enter this move file. The old name comes, right? myfile.m is a new to old file.m. So you can see that rename, this is the old name, this is the new name. So you can do this easily by using this particular type of commands. That, but anyway, so normally we don't use we don't type something to make these changes, but anyway, right? Inside a function or a program, if you want to do something, I need the uh, function, right? Normally we use the mouse, we go to that, we right click and we do the changes, right? But inside a code, while you run the code, if you want to make some changes of this sort, then you see that these all these commands become very important for us. All right, so we use all these commands to make the required changes in this.